So Unit 3, 9 weeks review. We're on the third page, number 11. All right, here it asks us to find the distance between G and H. Remember distance formula, this was back in Unit 1. Or you can, instead of distance formula, which will be given to you with the formulas, you could also do the Pythagorean theorem strategy. Since you have it graphed, you could create the right triangle. So remember, I could do this and forming. So I could form a right triangle here. Okay, so when that, I can count the sides. Okay, well, yeah, I'm going over the review if you want to go up with that. So here we've got a distance vertically of 1, 2, 3, 4, 5, 6, and horizontally of 2. So you can do it this way if you, and both of these will be on the formula chart. If you think of this in terms of Pythagorean theorem, where A and B are the legs and C is the hypotenuse, you can plug that in here. Remember, this would be A and B, and the distance of the segment there, that would be C, because that's across from the 90-degree angle created. So you could plug this in and have 6 squared plus 2 squared under the radical. And you can do all of this in Desmo, so you don't have to do this by hand. But that comes out to 13, or no, sorry, 40 under the radical. And it says to round to the nearest tenth if necessary. Okay, so that is approximately, means about, because it's not going to be exact because we're going to round. So when you do the square root of 40, it comes out to about 6.3245. I'm going to write several of these and then go over the rounding process with you again. Okay, and it's further than that, but that's enough. So when it says nearest tenth, the tenth is one place after the decimal, but you always look one past that, whatever you're rounding to see if that should round it up or not. So the 3 is in the 10th place, but I look at the 2. Should the 2 round the 3 up to a 4, or is it going to stay a 3? It's going to stay a 3. Okay, if the number that you to the right of what you're rounding place value is 5 or higher, then it rounds it up. This does not round it up, so this is going to just stay 6.3. So that is the distance from G to H. Now the actual distance formula, if you didn't want to do it as a triangle and make that right triangle and do Pythagorean theorem, remember you can do the change in X squared plus the change in Y squared, all under the radical like this, and you could calculate it that way. And if you were doing it this way, you would have to come over here and get the ordered pair of G, which would have been at -2, -3. And H, which is at 0, 3. And then you would have identified, okay, my X's would go here, and my Y's would go here, and you would calculate that and let Desmos do its thing, and it would give you this same answer. Okay, so you can do it either method that you choose. All right. Number 12 says, find the equation of a line that passes through 5, -4 and is parallel to this line. So this line is in slope-intercept form. So what part of this is your slope of this given line? Y equals -1/5 x plus 3. What part of that is the slope? -1/5. And the question wants us to write the equation of a line that is parallel to that. And parallel means what? The same slope. Okay, so parallel means I'm going to use the same slope. And then they tell us that it goes through this point. So that's going to be my x1, y1. And I've got a point and I've got slope. So I'm using point slope form. So the point, the x is 5, the y is -4, and the slope is -1/5. Now again, it says that you can write the equation. It does not specify slope-intercept or point slope form. So I would simplify the minus a negative. That becomes a plus. And you could leave it like this. Or you could convert it into slope-intercept form. You could solve for y like we've done on some of the past examples. But you can just leave it like this. Or if all of your answers, if you get to this point and all of your answer choices are in y equals, you could plug them in and look at the graph and see which one is the same as this. That would be one way to check it. Okay, you could also in Desmos, if you have multiple choice, I would go in Desmos and plot the point that we want to go through. I would graph this line that we want to be parallel to, and then I would graph the answer choices. So let me show you what I mean. So the point is 5, -4. So I would put this 5, -4 in here. Okay, and then the equation I came up with, or this could be like your answer choice that you're checking, is y plus 4 times -1/5 x, or 1/5 times x minus 5. And then your original equation that you were trying to be parallel to is y equals -1/5 x plus 3. So here's what I mean when I say I put the original equation in blue, I put the point we want to go through, and then I put the answer choices. And if this is the answer choice, you can have a visual that shows, oh yeah, it goes through that point, and does it look parallel to the blue line? It sure does. I don't see it intersecting. Zoom way out and see if it ever intersects. Those are parallel lines. Okay, and you could just check every answer choice. Like if I had another choice that was something like this, I could obviously see, oh, that's parallel, but it doesn't go through the point it's supposed to, so that's not it. Does that make sense? So use Desmos to your advantage. Okay, check, work backward from your answer choices if you need to. All right, 13 says which of the equations represents a line parallel to the given line. So again, what part of this is the slope? Yeah, the slope is that when you're in y equals mx plus b, there's your slope in front of x. So the slope is -2, and now you need to know what parallel slopes are. What's parallel? Same slope. So we need one that has a -2 slope. Okay, A and B are both written in y equals, so you can see the slope. Here the slope is 2, here it's -2. So that's the one we want, that -2. This one's wrong because it's not negative. These are not in y equals, so it's harder to see. So you could read, well, this is in y equals, it's just on the other side. But you can see in front of the x is a 2, so that's wrong because it should be negative. And then this one, if I added the 2x to the other side, if I moved it, it would become positive 2x. So it would be a positive 2 slope. So that's wrong. Okay, so that was B. That was the only one that had the correct same slope, parallel slope. 14 says line AB passing through point A and B and gives us the coordinates. Which of the following is an equation of a line parallel to AB that passes through point P at 4, 7? So again, we don't know the slope of AB. We have to find it. They tell us that AB goes through these 2 points. So I've got to do slope formula, which is the change in y over the change in x. So I'm going to pick my x's are -7 and 7. And then my y's are -4 and 0. So I'm going to calculate -7 minus 7, that's -14 over -4. A negative divided by a negative is a positive. Okay, so it's a positive, and then 14 over 4 will reduce to 7 over 2. And your calculator will reduce that. If you type in all of this, it'll come out and tell you it's 7 over 2. You don't have to do it by hand. Okay, so I know the given line has a slope of 7 over 2, and they want us to pick a line parallel to that. So it's got to have the same slope. So it's got to have, did we do that wrong? We did. Ah, I see what I did. Do you see how I wrote the X's on top in blue? Nobody stopped me. I made a mistake. And that's good. I mean, it's fine. So you can see none of those were there. So we knew we made a mistake. So we go back and check it. Slope is the change in y over the change in x. So I need to switch my x's and y's. Okay, the -7 minus 7 should have been on the bottom. And the y's on top. So we end up, that should be -4 over -14. So I just had the reciprocal, I had it wrong, but it still comes out positive. And instead of 7 over 2, it's 2 over 7. So we're looking for one that has a 2 over 7 slope, and it's positive. So immediately I can see this is wrong because it's negative. This is wrong because it's negative. So B and D are out. Okay, so both A and C have a 2 over 7 slope. So now I have to see which one goes through this point. Now I can do this algebraically, but again, I highly recommend y'all use Desmos. Okay, so plug in the point you want it to go through, 4, 7. Okay, so I'm going to put there's 0.47. And I'm going to put the 2 equations that are my choices. It's 2 over 7 x plus 41 over 7. Does that go through that point? It goes through that point. And if you checked the other answer choice is the only difference is there's a minus here. And you can see that one, you have a visual. It doesn't go through that point, does it? So you know it's got to be the one that had the plus, the plus here. So that has the correct slope and it goes through that point. That had the wrong sign. So far, so good? All right, last one on this page. Determine the angle pair relationship. Now this is taking it back to our most recent stuff, Unit 3. This is what you were doing your project the angle pair relationships that represent each angle pair below. So we're naming them. So before I start this, I'm going to color code my congruent angles, just as a reminder. So those 4 are the obtuse appearing angles, and these 4 are the acute appearing angles. Do y'all agree? Okay, so we know those blue ones should be congruent to each other in the yellow, but we want to name their relationship. So here, 5 and 8. So 5 is to 8. Those are both yellow, right? I know they're going to be congruent, but that's not the name of the relationship. The name, when you are at the same intersection, see, we don't even need this other intersection, but for 5 and 8 to be across an intersection from each other, who remembers what that's called? Starts with a V. Vertical angles. So those are vertical angles. Cross from each other at an intersection. And I'm going to point out again, remember the link that I shared with y'all? I put it on your project page. I'm going to pull it up here again. It's on the project page. I also just put it in our modules, like with our notes and stuff too. So you can either go to the project page or here, this link that says visual representations of angle relationships. Some of y'all may want to use this to study. So I can look and see, here's vertical angle pairs. They're across from each other at intersections. Okay, so that's vertical angle pairs are across from each other at the same intersection. Okay, now it wants us to do 7 and 3. I'm trying to get rid of these markings. Not that. All right, so I'm going to put a mark on 7 and 3. So here's 3. No. Here's 3 and here's 7. Those are both blue, aren't they? Those should be congruent to each other. 3 is in the bottom left corner of the top intersection. 7 is in the bottom left corner of the bottom intersection. What's that called when they're in the same spot at their intersection? Starts with a C. Corresponding. They're in corresponding locations. Good. And I'm going to abbreviate angles because I'm running out of room. And now, again, if you go to that website, if I click on corresponding, you can see red to red, blue to blue, green to green, purple to purple. And you can change the size of your angles and stuff. That doesn't matter. It's the location, top left to top left, bottom left to bottom left, etc. Okay, those are corresponding angles. And I'm actually going to add over here, I know it didn't ask it, but I'm going to say that these are congruent. Vertical angles are congruent, corresponding angles are congruent. Okay, now we want to look at 4 and 6. Okay, so angle 4 and then angle 6. Those are different colors, aren't they? Yellow and blue. So I know those are not supposed to be congruent. I know they're supposed to add to 180. Do y'all agree? But what's the name of their relationship? Are they inside or outside the parallel lines? Inside. They're in between. So they're interior. Now, are they on the transversal? Are they on the same side of the transversal or alternate sides? Same side. So they're same side interior. All right, now 3 and 4. Well, I've already got 4 marked, so let me just get rid of the 6. So 3 is here. 3 is also blue and 4 is yellow. So again, I know that these two should add to 180 because one's obtuse, one's acute looking. but they're at the same intersection. So we don't need the second parallel line here. We don't need parallel lines to have this relationship. They're at the same intersection. They're next to each other on a straight line. Who remembers what that's called? They form a line together. Line is a part of the name. Linear pair. Good. That is a linear pair. Because they form a line together. They're next to each other. They have a shared side. All right, let's see, 3 and 6. So 3 to 6, those are both blue, so those should be congruent to each other. They're both in between the parallel lines, so they're interior, but they're on opposite sides of the transversal. So this one is alternate interior. And last but not least, take a look at 2 and 7. So 2 to 7, also both blue, so I know they're supposed to be congruent. They're on alternate sides of the transversal, but they're outside the parallel lines, so they're exterior. So alternate exterior. So those are those angle relationships that you need to know. You need to know the names of them, and you need to know when they're congruent versus supplementary, meaning they add to 180. All right, I'm going to stop this video here. I'll post all the videos after school today.